So, what do you think a bird soaring through the sky, a bolt of lightning, and, well, even the food you eat, what do they all have in common? Yep, you guessed it. They're all about energy. And over the next few minutes, we're going to unpack this incredible force that literally powers our entire world. So, here's our roadmap. We'll start with the basics of what energy is, then jump into potential versus kinetic. We'll touch on two types of potential energy, look at how it transforms, and then see it in action all around us. Finally, we'll wrap up with the key takeaways. Let's do it. Okay, first things first. Let's build a solid foundation. What are we really talking about when we use that word energy? When you boil it all down, energy is actually pretty simple. It's just the capacity to do work. Or you could say it's the power to make stuff happen, to cause change. It's the reason things can move, or heat up, or even grow. Just think of it as the universe's ultimate get-up-and-go power. So energy usually pops up in one of two major forms. You can almost think of them as two sides of the same coin. You've got the energy that's just kind of waiting, and then you have the energy that's in action. Let's talk about kinetic energy first. This one is all about motion. Seriously, it's that simple. If something's moving, it has kinetic energy. A car cruising down the highway, a ball rolling down a hill, even the wind. Yep, that's all kinetic energy doing its thing. Potential energy, though, is the flip side. It's all about stored energy. It's the energy something has simply because of where it is or its current state. So imagine that ball again, but this time you're holding it at the very top of a ramp. It's perfectly still, but it's just packed with potential, totally ready to roll. So let's break it down real simple. Kinetic is the energy of motion. It's about doing something. Potential is the energy of position. It's stored up, just waiting for its moment to be released. Doing versus waiting. That's the core idea. All right, so if potential energy is basically stored energy, how exactly does it get stored? Well, let's check out two of the most common ways this happens.
First, you've got gravitational potential energy. This one's all about height. The higher up an object is, the more stored energy it has, all thanks to gravity. Then there's elastic potential energy. This is all about stretching or squishing things. When you pull back a rubber band or push down on a spring, you're literally loading it up with elastic potential energy.
Okay, now this is where it gets really cool. See, energy almost never just stays in one form. It's constantly changing, constantly transforming. And honestly, that's what makes it so incredibly powerful. And this brings us to one of the most important rules in all of physics. It says that energy can't be created or destroyed. It can only be converted from one form to another. Think about that. The total amount of energy in the entire universe never changes. It just swaps outfits. And once you know what to look for, you start seeing these energy makeovers happening absolutely everywhere. Let's look at a hydroelectric dam. All that water held way up high behind the dam, that's basically a giant battery packed with gravitational potential energy. And the moment that water's released, bam, it unleashes all that stored power. It becomes moving energy, spinning huge turbines and generating the electricity that powers our homes. Or how about a windmill? The wind itself, that's pure kinetic energy, right? It's just moving air. Well, that moving air pushes the blades, and that motion gets converted into a totally different kind of power. It turns the invisible force of the wind into the very real electricity that lights up our world. And nature is the ultimate expert at this. Take plants. They soak up energy from sunlight, which is a form of radiation, and through this amazing process called photosynthesis, they turn it into chemical energy. That's the food they use to grow. Even something as simple as a battery in your remote control. What is it? It's just a little container of stored chemical energy. But the second you pop it in and turn something on, you complete the circuit, a chemical reaction kicks off, and it starts pumping out a flow of electricity right when you need it. But here's the thing. These amazing energy transformations, they're not just happening in giant power plants or deep in a forest. Nope, they're happening all around us, all the time in our everyday lives. I mean, just think about the stuff you use every day. An electric lamp, it takes in electrical energy and spits out light and heat. A microphone, it does the complete opposite of a speaker. It takes in sound energy and turns it into an electrical signal. Even a campfire is an energy conversion. It's releasing the chemical energy stored in the wood as heat and light. And your car's engine? That's basically a controlled explosion machine, turning heat energy from gasoline into the mechanical energy that moves you down the road. Okay, wow, we have covered a ton of ground. So let's take a second and do a quick recap of the most important things you should walk away with from this explainer. So, number 1, energy is just the capacity to do work or cause change. Got it? Number 2, it mainly shows up as kinetic, that's motion, and potential, which is stored energy. Number 3, that stored potential energy usually has to do with an object's position, like its height, or its condition, like being stretched. And number 4, this is the big one, energy is always conserved. It constantly changes form, but it's never, ever lost. And that brings us to one final thought to leave you with. From the sunshine that fuels our entire planet to the chemical reactions that power our own bodies, we are literally swimming in a sea of constant, incredible energy conversions. So the big question for all of us is, where will the next great energy conversion come from? What new and incredible ways will we find to harness all this power?